Login accepted.
Hello, Poland, and good day. This was a kind of a nice intro. I kind of like it. Every conference has something really fancy. Anyways, let's talk about Qwik framework. So it's a new kind of framework, but first, a bit of an introduction. Hi, I'm Miško. I'm the CTO of Builder, and I did this thing called Angular, AngularJS, Karma, Clean Code Talks. You might have heard of them before. If not, welcome. I currently work for Builder, and we do this thing called Visual Development Platform. And I need to tell you a little bit about it so that the Qwik makes a little more sense. So like 30 seconds. Let's say you have a site on the left, and you want a site on the right. And this happens all the time, right? Because you have marketing people, and the marketing people are like, we need to change the sale, we need to change the featured products, whatever. So they constantly ask you to do this, and so you go and make a change to your code base, such as this, and you commit this, but you don't like this because you don't really want to do this, right? You want to work something exciting, some fun projects. And so you say, I know how to solve this problem. I'm going to integrate a CMS system. I'm going to do something like this, and now marketing can go and change these values independently, and they don't have to bug me. Problem is that marketing will come up with new ideas, like we want 2 sales concurrently. Can't do that. We want to make the color red. Can't do that, right? And so even though you don't have to help them every step of the way, you still have to help them quite a lot. So what's the alternative? The alternative is you can install what Builder does, and then you grab the code in the middle. The last line is kind of important, the registered component. You can actually have your custom components in there, and then you basically give marketing whatever they want. So we have a lot of customers like this, and they're basically e-commerce customers, and they complain to us that their website is slow. Not because of the code we have. We actually don't actually add anything. It's all server-side pre-rendered, but their websites actually start up faster, and so it would be great if we could go to our customers and say, hey, we can make your website even quicker. So before I show you this, let me take a little video. So let me show you what I mean by that. So on the left is a website built using standard technologies. This happened to be React and Next.js. On the right is a website built using Qwik. Let me play the video again and pay attention to when the color changes. When the color changes, that JavaScript is finished executing. The thing on the left, the reason why it's static, it takes so forever, is that it's doing something called hydration. And hydration is the thing that makes the startup of websites slow. And all current frameworks suffer from this. Whether you are React, Angular, Vue, Svelte, Solid, you have a hydration problem. And so this is the bit that we're trying to solve. So Qwik is a framework designed specifically for this. And now you might be asking yourself, doesn't the world have enough frameworks? Probably. But Qwik is fundamentally different. It takes a very, very different approach to solving this particular problem. And that's kind of what I want to talk to you about, is just how different it is. Now, the goal of Qwik is one specific goal, and that is to have 100 out of 100 no matter the complexity of your website, right? A lot of websites can get you 100 when it's nice and simple, but once you have a real-world e-commerce website or real-world thing, and you include all the script tags and everything, you're not getting 100 out of 100. And so Qwik can do this for you, and so I'm going to show you how. Now, why does this matter? Well, it matters because, there's a lot of evidence that basically says that if your website is slow, you are not going to make a lot of money because there's conversions that needs to happen. People, they kind of put something to shopping cart, it takes forever. They say, you know what, I don't really need it, they leave. Google page speed actually feeds into the SEO ranking. So if your website is slow, it will be ranked lower on search engines. And so you have, especially as an e-commerce website, you have extremely high need to figure out how to make your website faster. But if you look at what actually you have in the wild, you'll notice that just about every e-commerce website fails the core web vitals, right? So this is Google basically grading your website in terms of performance, and just about every website fails. And even Amazon, that they have all the money in the world, and they totally understand, and they even have reports where they talk about just how important it is for Amazon to be super fast. Even they have trouble getting a good enough score, right? And so the way we work today as an industry, we kind of say the developer messed up. The developer doesn't know what they're doing, right? And I could maybe believe that if there would be examples of sites that are actually fast. The thing is, as an industry, there is no actual production website that passes Core Web Vitals. And I mean production, I don't mean toy websites, right? And so I am going to argue that the issue isn't the developers, the issue is the tooling we have and the mental model we have and the way we build websites, right? And so what Qwik is about is not necessarily about the DX of building the website, although the DX is very nice. It's more about this particular problem of like, how do we get the website to be fast? Okay, so the thing I'm going to try to convince you of is that the reason your website is slow is because JavaScript. Now, maybe for some of you this is self-obvious, but this is a graph of how much JavaScript there is in a browser over time. And as you can see, it just keeps getting higher, and there doesn't seem to be any stopping ground. And some people will say, like, well, we had Amazon 15 years ago. Like, you know, people are just getting worse at adding JavaScript. And I'm going to disagree, and I'm going to say what the website does today is a lot more powerful than what it did 15 years ago, right? So the reason why we have more code is because the sites are actually more powerful. And if you go back in time and you ship less code, your customers aren't going to like it. So we need to, and this trend will, I think, continue. We will continue to have more and more code in the browser. And so how do we fix this? So we built this tool called Performance Insight. To kind of see how can you pass your code? Can you pass the website? So let's just pick Priceline.com. If you take Priceline.com and you send it to Google Page Speed Score, you get 36 and you get 25 seconds on a mobile device, right? This is crazy, which means on a mobile device, probably a lower-end mobile device, right? It will take you 25 seconds before you can interact with this particular thing. And you can see why, you know, Priceline would be highly motivated to improve this. So there's a couple of things that we can do. We can optimize images, and we did that for Priceline, and we got the same exact score, which means that Priceline is already doing a wonderful job with the images. We do the same thing for CSS. Again, same score. They're already doing a wonderful job. But then we basically disabled JavaScript, and all of a sudden, wow, look at that performance number. That's a huge jump, right? So the question is, how can we make websites that are fully interactive, just as they are today, but stop relying on this much JavaScript, right? This is basically the core principle of Qwik. And so we did this for all top 50 e-commerce sites, and as you can see, the first column, it's all red. There are a few yellows, but for the most part, it's red. And you can see that optimizing images helps a little bit on average. Optimizing CSS also helps. What this tells me that as an industry, we're doing a good job on those two things, right? We really don't need help on that. But when it comes to JavaScript, oh my, we can really improve the performance of the sites if we could just like do something about these ridiculous JavaScript bundles that we have. Okay, so where is the problem? So the problem comes down to something that in an industry is known as hydration. And so the top level basically shows a classical framework. Again, all the current frameworks that are available to you really fall into this category, and they do something called hydration. And hydration, the way it works is that you have pre-rendered server-side HTML. Browsers are amazingly fast at displaying the HTML, so immediately you see the response, and you think you can click on something, but it's actually a dead site, so you can't do anything. So for that, you have to bootstrap the application. So let's go from the other end. What you really want is you want an interactive website. What that means in practice is there are listeners attached to your DOM, right? But in order to get interactive, you need to figure out where the listeners are. And the way you figure out where the listeners are is that you run the rendering for that particular component. Or for this matter, all components on a page, because you need listeners for everything on a page. Well, in order to get the rendering going, you need to have a state of the application. And in order to do all of these things, you actually have to download the application, right? So this fat arrow over here that's represented here is basically the fact that you need to download and execute the application in order to figure out where the listeners are. And the more complicated your application, the more fancier things you add to your application, the slower it gets, because the more expensive this bit gets over here, right? And so when you have a toy website, yeah, sure, you can get 100 out of 100. When you go a real production e-commerce site, or just about any website, right, you're going to discover that this thing here is huge. How huge? Well, for Priceline.com, that is 25 seconds on a mobile slow device. That's big, right? So how is Qwik different? Well, we also start with SSR, and we also have a bootstrap, but our bootstrap is super tiny. It's about 1 kilobyte, and it takes about 1 millisecond to execute on a desktop, and about 10 milliseconds on a mobile device. It's just tiny. But The thing to understand about this Bootstrap is that it has nothing to do with your application. You can think of it kind of like a polyfill. We need extra functionality for the browser, and we kind of polyfill it at this stage. And from here, we can go directly into the interactive mode. And I'll show you how that in a second. And because we're in an interactive, you can interact with the page. And it's at this point where the browser downloads JavaScript and updates and re-renders. Now, if Priceline.com is 25 seconds on a mobile device, we can't possibly pay 25 seconds for the first interaction. And this is what I mean by this super thin line. The framework knows how to download just the code necessary to execute that particular operation. Existing frameworks really have to download all the operations ahead of time. Qwik knows how to download just what is necessary. And oh, by the way, you can combine this with prefetching so that you don't have the issue of the first click, you have to wait for the network round trip. Okay, so this is what Qwik does. I'm going to take a slight detour and talk to you about Partytown, and then I'm going to show you a bunch of cool demos. Hopefully, you're going to be amazed and your mind will be blown. Okay, so there's really two kinds of code you have on your website. You have first-party code. That's the code you're writing using your favorite framework. And you have a third-party code, which is the thing that marketing asks you to put on because they need it. Things like Google Tag Manager, things like Facebook Pixel, Analytics, HubSpot, Intercom, and so on. Google says that on average, when they search the web, they see about 21 scripts on the page on average, right? So that's a lot of stuff in a third-party code. Now, the problem with third-party code is just like hydration, it wants to execute all your application at the beginning. Third-party code also wants to initialize and do everything at the beginning, right? And so that creates huge congestion on your main thread. Now, modern phones are super fast and have multiple CPUs, and a lot of their speed is gained by doing things in parallel. But JavaScript is single-threaded, and so it doesn't matter how many cores you have, it's all getting squeezed through this one main thread. So what Partytown knows how to do is it knows how to take your third-party code and move it over to the web worker, and then execute it on a web worker. And that's basically executing on a separate CPU core, which doesn't impact the main thread. And we can also do lots of tricks like sandboxing and so on. So for your third-party code, you should look into Partytown. You should just install it. It works with every framework, every site you have out there. And it will immediately give you probably like 20-point increase on Google page speed. Anyway, so that's a little side note. So let's do some demos. OK. Let's start from the very, very beginning. Let's do a very simple demo of just a hello world. And the thing to kind of notice is, if I open up the network tab, I'm running currently in dev mode, so I'm filtering out byte hot module reloading, so that I'm just ignoring this. But besides byte, you're going to see is that nothing gets downloaded when I go visit this page. Now, this page is static, so that's not that impressive, right? Any framework, you can just disable the JavaScript if it's static, and it just works. The only difference here is that kind of Qwik figured this out on its own. I didn't have to tell it that it's static. It just kind of looked at it and said, yep, static code, nothing to ship. So that's not that exciting. Oh, the only thing I want to show you before is that what does it look like? This is the code for the hello world. If you come from a JSX background or React background, this should look extremely familiar to you. You should look at this and be like, yep, looks like React, great. There is one difference, and that's this component $, and I'm going to talk about $sign in a second, so I'm not going to go there just yet. But fundamentally, that's kind of the developer experience you have. If you're familiar with React, this should be very familiar for you as well. OK, so let's go to a counter. So we come to a counter, and again, I want to show you nothing in a network tab. And it is when I start clicking buttons like hello, or when I hit click, does more code actually download. Again, this is a development mode where I want to show off all this capability, so I'm actually downloading these things late. In production, we would do prefetching, so that we would prefetch all this stuff ahead of time, so when you click, you don't have to wait for it. Now, you say, well, isn't prefetching the same thing as just loading it eagerly and doing hydration? And the answer is no. There's two big differences. First of all, Qwik can tree shake a lot of code and figure out stuff that you don't need. And then you say, well, I have a tree shaker over there. Yes, but your tree shaker is static, which means it has to say, like, it's possible this executes, whereas in Qwik world, it's dynamic. It looks at how the application actually ran. And based on that, it can do a lot better job of tree shaking and removing things. So that's the first difference. So basically, in Qwik, the worst possible case of downloading JavaScript is actually the best case for a standard framework. So a huge difference in the amount of code you download. The second difference is that Qwik doesn't actually have to execute the code, right? You download it and you keep it in the cache, but don't actually run it. Classical frameworks have to execute it. OK, so how does this magic work? So let's first go and look at how you implement counter. What you do is you say counter component, use store count 0, and in here we do data binding to the store. And then we have two buttons, one that increments the counter and a second one that prints console log to console, right? So nothing strange in here. Now, the thing I want you to notice is that this is a single file. And because it's a single file, not even a single file, it's a single function. And because it's a single function, how in the world are we going to lazy load parts of it, right? I mean, bundlers don't know how to do this. They don't know how to extract bits. So let me show you, let me refresh this again, and I'm going to click on just the hello, and I'm going to click on what actually got downloaded. So notice what got downloaded is literally just console.log ABC. Nothing else. Not even the framework downloaded. Just the thing that you actually asked it to do. Just this piece of code over here. On the other hand, if you go and click this button, we download the piece of code that increments the count, but we also import something from the framework. So this framework has to get downloaded. And then the second thing we have to download is we have to download the JSX. Can I make this thing smaller somehow? No, sorry, small tiny thing. The second thing we download is JSX. This is just JSX converted over to the object notation, right? But this is the template for it. And so the kind of the trick that Qwik knows how to do is it knows how to take closures and pull them out into a separate functions, separate files, and then knows how to bundle them. So what does this look like? Well, it looks something like this. Oops. It basically pulls out the code and puts it to a top level. So now you can go and download this particular thing. But notice what happens when you pull something up to top level. All of a sudden, store is complaining. It says, like, I don't know what store is. And that's because store was a closure. It knew what store was in this location, but it has no idea what store is once it gets lazy loaded. And I call this the function amnesia, or the fact that this is a closure. It's supposed to capture things. So actually, we can't do this. Instead, we do a little bit more complicated piece of code, and that is this. What we do is we put our piece of code here, right? This is our code, store count ++, but we have to restore store. And so we have a special function called, restore lexical scope, and that one allows us to return the store in here. Now, I'm going to change this thing a little bit, and I'm going to say console log, and I'm going to log the store instead of printing it, instead of incrementing it, right? And I want to show you what happens next. So when I change the behavior and I hit click, sure, I downloaded the behavior, but notice what didn't download. It didn't download the component because the framework correctly deduced, like, oh, in this particular case, you're printing the store out. So if I go to the console, I will see the store, but nothing actually needs to be re-rendered. So why should I go and download the re-rendering code, right? So the framework is extremely surgical about what information it actually needs to download to the client to make this thing work. OK, let's put it back to where it was. OK, so that's kind of the magical bit of Qwik. Now let me back up a little bit, and let me show you a more complicated example. And so far we've been talking about individual components, right? And so when you have an individual component, there are really not many choices of the things you can download. Oh, sorry, the thing I forgot to mention. Sorry, a little detour. These dollar signs. What do these dollar signs mean? So every time you see a dollar sign, you should be thinking in your head, a lazy loaded boundary. The dollar sign is both a message to the developer saying, magic's happening here, and therefore you have to follow certain rules. Namely, you have to realize that that's a lazy loaded boundary, and so as a result, you can't just capture anything. You can only capture things that are serializable, right? So things like promises are not capturable because, well, like how do you serialize a promise, right? So there's a little bit of understanding from the point of view of developer, but the $ also tells we have this special piece of code called the optimizer that knows how to rearrange your code base so that the lazy loading can happen later, right? So you write hints, then, and by the way, these hints are part of the API, so it's not like I can not put a $ there, otherwise, the TypeScript will scream at me. So it's just naturally how you write your code. So these $ are hints for the optimizer to rearrange your code base, and then rearranged code base gets fed into either Vite or Rollup to create your ideal bundles, and then the runtime then knows how to cooperate with the optimizer to kind of recover all of these pieces. So in this particular case, when I hit plus, I'm incrementing the bit here, right? And so how does that work? So let's go to the button, and what you see here is that we have serialized a on-click listener. The reason we can do this, the reason why we don't have to download JavaScript is because we know ahead of time where all the listeners are, right? When the code executed on a server, and we did server-side pre-rendering, the server code, most frameworks, when they do server-side rendering, they throw away the listeners, right? Because they're like, it's a server. It's not like I can do anything with it, and they throw it away. And so if you look at most frameworks' output, it would just say button and nothing else on it. But in Qwik, we know that there's a listener there, and so we insert this special attribute tag, which gives us the URL and the symbol that has to be downloaded and executed. And on the end of it is actually this special 0 thing over here. And this 0 is a pointer to the state of the application. Oops, that's the Qwik loader. Let me refresh this again. Here is our JSON. So this basically tells us where to go. The URL, sorry, not the URL, the state of the object that needs to be recovered to go there. So I'm actually showing you a different demo. Sorry, which was supposed to be on the counter. I apologize. Okay, so here is our JSON, and the JSON has the state, which is the count 0. So when I click on this button, right, to download the listener, the function has amnesia and says, yeah, but I need store, and so we need to recover it, and we need to say, actually, the count is 0. So the function can go and increment it to count 1. And then the framework has to recognize the fact, like, oh, you modified this thing, and there is a listener, right? That's basically shown up over here. So inside of the JSON, oops, we have a listener right here that basically says, if somebody modifies the count, you need to go notify that component over there because it has to re-render, right? And so by breaking everything up into pieces, we can be extremely lazy about it. So let me show you a more lazy version of it. So here is another more complicated counter example. And in this case, I can click button, and then 2 seconds later, the debounce gets the copy, right? So it's a kind of a delay between me clicking and me downloading. Now, watch the network tab again. Click, whole bunch of thing downloads, 2 seconds later, more code downloads, right? Because there was a delay between the two. Because the philosophy of Qwik is that you shouldn't download any piece of code that is not needed at this very moment, right? Because if you're downloading code that you don't need, you're just wasting bandwidth. And so the whole thing is set up so that we are extremely lazy. Our philosophy is you only download the code when you actually need to execute it. Okay, so this is a little more complicated example. And the thing I want to show is, here's reactivity. And here, again, we have our store. We have count and debounce count. And we have a watch. And what watch says is, go keep track of the count. If the count changes, I want to know about it. Print out that the count has changed, and set up a timer for 2 seconds, and then return a cleanup. So if the count changes before 2 seconds is up, we clear the previous timer, and then we set up the new timer, right? Now, the reason why this is important is because on a server, we execute this information, right? So on a server, we know that there is somebody listening to the count. And this information gets serialized and sent to the client. And so even though there is no code on the client, when you click on it, at that time, we can figure out, like, oh, we also have to get that piece of code over there. We then say reactivity renders, and then we create the component with the button. And in here, we have a child. We pass the store to it. The child prints the count. And then there's a grandchild that prints the debounce count. Now, the reason I'm showing you this is because, let's clear this, let's refresh. And so what you see on a server, well, it's not going to help. Okay, let me do this one more time. Okay, what you see on a server is that server rendered grandchild. It had to, right, because that's the component. It rendered, sorry, I'm starting from the wrong location. The server rendered reactivity. It rendered the count changed. It rendered the child and rendered the grandchild, right? It had to do that because that's the application and it had no choice about it. But if you go to the client and I go to the console and I hit plus, I see that the count changed, the child rendered, 2 seconds later the grandchild rendered, but the reactivity component never re-rendered, right? The framework correctly deduced that that component never changes, and so why should we send code to the client, or why should we send, do anything with it, for that matter, right? And so this is kind of the philosophy of Qwik, is that the way we get fast is not by making the application smaller, but just being smarter about what we ship to the browser, right? Instead of front-loading everything ahead of time and then running hydration to kind of do this stuff, can we figure out ways to kind of serialize all the information to HTML and then only download the necessary JavaScript that we need? Okay, so let me show you my favorite demo. And whenever I show this demo, I want you to think about how you would do this in your favorite framework. So the demo here is that there's just 2 clocks on the bottom, and they actually show the current time, and you can see every second they tick. And so that in itself is not that amazing. What's amazing is, again, network tab, nothing downloaded, right? When I scroll it into the view, watch this. The moment I scroll them into the view, they download the code and wake themselves up. Now, let me show this to you again from the point of view of the DOM. And this is this one, this is this one. Okay, so from the point of view of the DOM, again, refresh the page. And, oops, oh really, you're going to close it on me? Okay, so here are the hands, the hour, minute, and seconds. And of course, they're not updating because there's no JavaScript on a client, right? When I scroll the first clock into view, now I'm updating it every second. But the second clock is still asleep. It's not doing anything. When I scroll the second clock into the view, it wakes up that particular component. Now, again, just think about it. How would you do this in your current framework? I mean, this is clock. This is a trivial amount of code. But let's say you have a component that's very expensive, and you really don't want to delay bootstrapping it because, well, I mean, it's below the fold, right? Why should I do this? This kind of stuff is super difficult in classical frameworks. Turns out it's extremely trivial in Qwik. So here's our clock example. We have a top-level component called clock. And this JSX here is really just to create a bunch of stuff so that we have below-the-fold stuff. And here are the 2 copies of my clock. So the clock says I need to load a bunch of styles. I set up a store for my angles for my hour, minute, and second. And I'm going to use something called the use client effect. For people who are React folks, they're going to say, well, that looks just like use effect. It is. We do have to actually make a distinction between client and server, because the thing that Qwik knows how to do is kind of how to start its life on a server and then seamlessly transition to the client. And so sometimes it's kind of necessary to kind of distinguish when you want to run code where. Now, what this code does is it just has an update function that grabs the time and computes the angles. That's not interesting, so we call the update, and we call the set interval so that we update it every 1 second, and of course we have clear interval on the end. The thing is, when does this function get run? So when you have a typical framework, and the framework that requires hydration, then the answer is very simple. The function gets run on hydration, right? I mean, that's the only place where you can kind of run it. But because there is no hydration in Qwik, the framework kind of just resumes where it left off, when exactly should you run it? And so you can put there's an additional argument that you can put into this function, and this argument basically says, when should it be run? And the options are immediately when it's on the client, or the second option, which is the default option, is when a component becomes visible, right? And so by default, in Qwik, you just automatically do the right thing. You didn't have to do extra things as a developer. It just automatically happened. And again, notice that there are $ everywhere, right? And these $ mean this is lazy loadable, and then the clock itself is lazy loadable, right? So the 2 network tabs that we have, first, we downloaded the use effect that knows how to run every second and update the clock. And then, because it changed the state of the system, we have to download the JSX so we can re-render that component, but just that component, right? What you don't see here is the parent component being rendered. Because, well, that one is static, so why would you download and render that, right? Okay, so the thing that I've been kind of showing you up to this point is kind of the tree shaking capabilities of the framework. And this is where the static versus dynamic comes into play, right? If you have a static tree shaker that looks at it at the time of compilation, that tree shaker has no choice but to say like, well, the application gets bootstrapped at the Qwik app, right? It gets bootstrapped at this location here, and this thing has a reference to this thing. Therefore, both of these things have to come together in a single file, right? And that's kind of the problem with the classical things. The thing that Qwik knows how to do is basically break this up and say, actually, at the server, I have to execute all the components. There, I have no choice. But once it executes on a server and I ship it to the client, at the client, I don't ever have to re-render this part. So why send it? Why waste time sending it and executing it at the client? But the same thing can also be done for data. So here is an example of Hacker News, and this is a standard demo that everybody has. And in order to get this text, we had to make a JSON call to the Hacker News API website, service point, whatever, right? So we made some REST call to get the data. And once the data showed up on a server, we had to merge it with our application. And the thing I talked about earlier is how the system needs to serialize the data, right? So if you click on an interaction, you want to make sure that like when we hit the counter and we hit the +1, we needed to know what are we +1ing from? Like, where does the counter start from? Is it 0, 1, 10, 11? Like, what is it, right? So we need to know the initial state. And so the initial state gets serialized into this Qwik JSON object that we have over here. And so in this particular case, there's a whole bunch of components that are on a server, and these components read data from the REST API that came from the system, and so they essentially created subscriptions. But because there isn't a way to edit any of this data, right? This application doesn't allow you to do the editing. The system correctly deduced that sending the state of the application, state being the actual JSON that came from the REST API, to the client would be pointless because, well, there's no way to kind of do anything with it. And so not only did it successfully recognize that there is no behavior here, it also successfully recognized that the data doesn't have to be sent across either and remove that from the output. Now, let's go and drill down to a subcomponent. And now, if you look at the state of the system, we have some data that got serialized. And specifically, you see this open, true, open, true. What these things refer to is that now there is behavior. Now this is not a static page. Now I can click on the button and I can collapse it and I can expand it, right? So this collapsing is an interactive component. And obviously, when I do so, network tab, let me refresh this again. No code available, right? I mean, no code downloaded. When I click on it, I need to download code. Now, the thing to notice is, oops, I did not want to do that, but actually that's kind of useful. The thing that we have here is that we're changing the state from open to close, right? That's the only thing we're doing. And the second part we're doing is, just downloading the JSX for the component that knows how to expand and collapse, right? This is not a lot of code here, as you can see. Now, but what didn't get downloaded is all of the JSX for rendering this page, right? This page has a menu bar, there's a header, there's a footer, there is a comment, there's a text in here. Like, huge amount of JSX had to be written to produce this, and yet the only amount of JSX we download is this, which is quite trivial, right? And again, think about your existing frameworks. How would they solve this particular problem? And you will recognize that, two things will happen. First of all, they will download all of the state of the framework inside of this huge data object, right? So all of the data that you see here, that the text would be sent twice, once in HTML and once in the JSON. And the second thing these frameworks will have to do is they will have to download all of the JSX, all components on a page, regardless if they're static or not. Okay. And let's do a next demo. So my next demo is also my favorite demo. I know I have two favorites, but in a very different way. So here is a to-do app, And again, I'm going to show you the network tab. And the thing I want you to see is that as I interact with the site, code downloads, right? When I hit enter, code downloads. When I check something, code downloads. As I am working with the application, more and more of the application downloads. Now, even if I click on everything, I kind of already hopefully convinced you that not all code will download because the Qwik will properly recognize the fact that certain things are static and so it will never ship this. And of course, we never had to pay for hydration. So let's make a new item. Hit enter. And so now we have changed the state of the application. And you kind of noticed earlier is that when you interact with the app, it kind of consumes its state. So, but one of the things we can do is we can recover the state and we can say pause the application. As you can see right now, the application is resumed. When I hit this button, it becomes, it becomes paused. And what it generated is basically the state of the app. And if you look into the state of the app, you should see that somewhere in here we have our new item. Let's see, where are we? Builder, yeah, okay. Somewhere here's a new item. No, where is it? Okay, trust me, somewhere in here is a new item. Take my word for it. Okay, so now let's do something that you absolutely cannot do, and it would be bonkers to do everywhere else. We are going to do copy outer HTML, and let's open up a new tab. And in here, we're going to come here and delete the HTML. Okay, so we delete the HTML, nothing here, right? Blank page. And now we do edit as HTML, and I'm going to paste the HTML from the other side. Now, the fact that the application showed up over here, this would happen everywhere, right? But like what we have now, if this would be any other framework, what you would have is just a static HTML that is not interactive. There's nothing you can do with it. And even if you somehow could figure out how to bootstrap it, it would reset itself to the initial state, and so the new item would disappear. The crazy thing about Qwik is because it's all lazy loadable, you can just keep adding new stuff. It's just interactive. You just keep using it like before. And it keeps working. That is a cool party trick. But is it actually useful? And the answer is yes, it's useful for two reasons. First of all, this is exactly how we get the application from the server to the client. We execute the application on a server, we need a lot more code on a server, and then we save it, we pause it, which generates the state of the system inside of the script tag, and then we can take that application and move it to the client. In this case, using HTML, we send it to the browser renders it, and we have this tiny polyfill that knows how to read these on-click attributes, right? And then when you interact with it, that's when the code starts loading, and the system knows how to recover the state that was serialized in that huge JSON blob, right? And so what we say is that Qwik applications are resumable, right? In contrast to hydration systems that require you to re-execute. In other words, what I call them is replayable, because they replay all of the work that the server just did, right? If you navigate to a page and you do server-side pre-rendering, you're essentially executing your application. The framework serializes the HTML on a server, but throws away information such as the location of the listeners, and it throws away its internal state of the framework. Internal state being the, where are the component boundaries and what are the props and children and all these other things that I need to know when I re-render. All that stuff gets thrown away, and so just HTML gets sent to the client, and now on a client, the only way to kind of continue this is to redo everything the server just did in order to recover the listeners, and in order for the framework to recover the boundaries of the components and know how to render this going forward, right? And so I say the existing frameworks are replayable. They all suffer this particular thing. And so by being resumable, you basically take all the JavaScript that normally executes immediately when you visit the page, and you simply say you don't need it, like you don't execute it, right? And that's the reason why a Qwik app can go from 25-second demo that I showed you earlier for the price line to essentially no JavaScript being executed on the client. It's not completely zero, but it's pretty close to zero. Okay, so we did a to-do app trick, and what do we have here? Okay, so let's talk about how existing frameworks kind of work, and then I think I will open up to questions. So this is a typical, what I call monolith. What I mean by monolith is that if you have a component on this page, then you have no choice but to download it and execute it on hydration. So the way these frameworks work is they server-side HTML, so that shows up, and it's gray, meaning that it's not interactive. And so then they go fetch all the JavaScript, and all the JavaScript has to download. Then they parse it and they execute it. And as they execute it, they recover the listeners and make everything interactive, right? And so at this point, the user can go and interact with the page. The thing we paid for it is the download of all the JavaScript and execution of all the JavaScript. So most engineers are like, haha, I know, I'm going to solve the problem. I'm going to insert lazy loaded boundaries. And so they do that, and so the framework wakes up and then downloads the code, executes, and those are the lazy loaded boundaries. And so part of the stuff that you see is behind the lazy loaded boundary, but I still need to get it so that I can figure out where the listeners are. So whether or not it was a lazy loaded boundary doesn't matter. I have to cross that boundary. I have to make another request, download that code, and finish the execution. So putting lazy loaded boundaries on a current page, on a component that's actually visible on landing, is actually detrimental. Lazy loaded boundaries are great for components that are not currently visible on a page because you're decreasing the amount of code that you have to download to the client. But on the current page, when it's visible, sorry, you have to get it. Now, we have a new breed of things, frameworks called islands. And so in this particular case, is Astro. And what Astro says is, like, instead of having one big app, why don't you break it up into smaller apps? And like when I click here, I'm only going to hydrate this piece of code right here. And then when I click over here, I'm only going to do this over here. And so this helps. This is definitely an improvement. But it's not really useful for building true apps. It's useful for building like documentation websites. True apps require communication channels between components. And that's what a framework does, right? It's a communication channel. And because this is now two separate applications, you are left with no communication channel between these two applications. It's up to you to build one. Right? And it's not something we as engineers want to really worry about. And so instead, what we have is Qwik. And so the way Qwik works is that when I interact with a particular component, let's say this one, then only that component gets resumed. Right? That's the code that I download, and that's the component I wake up. But notice what happened there. What I didn't wake up are my parent components or my child components. And this is key. Nobody knows how to do that except for Qwik, which is like, how do you not cause a cascading effect by also waking up the parents and also waking up the children, right? Not only that, remember how in the island architecture we said we oftentimes need to communicate across component boundaries? Well, let's say this is add to shopping cart button right here. So if I click it, I also have to wake up the shopping cart, which is over here. Right? So Qwik understands the relationship between components and knows how to do intercomponent communication, even though no code is actually downloaded in the client. So styling is another thing. So styling is another interesting problem, which is, let's say you have a sibling loaded. A sibling has, well, let me style. Here's a sibling style right here, right? So in order to make it green and a box around it, we have a style for it. So if I add more siblings, I don't need to download the style for this component because, well, let me refresh. If I add sibling, what happened? Okay. I don't know what's happening here. Oh, sorry, I'm on the wrong page. That's what it is. Okay, no, is it? Okay, sorry, this is small. I don't know why it's not coming up. So here we go. So here's the styling. So we're downloading the code. We're downloading the rendering stuff, and so on. But what you don't see over here is we don't download the CSS because the system understands when it first rendered, an existing style was already loaded. But if we toggle a brand new component, not only do we have to download the component, we also have to download its CSS. So if you are looking at the head over here, let me refresh this again. Adding sibling does not change the head. Toggling one forces you to add it, right? And so again, we're extracting this thing to an extreme and saying not just the code, but styles and everything else that goes with it. Okay, last demo, and then I'm going to open it up for questions. And the last demo is basically very simple, which is you thought you actually saw a separate set of demo applications, but actually you just saw a single one. This is a single application. This application, in this page, I have everything in here. We have the listeners, we have the Qwik, we have a to-do example, and we have the clock. And all of this is completely lazy loadable, right? So can I make this smaller somehow? I don't know. I want to see the network tab. Here we go. So no JavaScript, scroll into clock, type text, more JavaScript. Like every time I interact with something, more JavaScript gets downloaded to the client, right? Okay, so with that, I'm going to pause and I'm going to ask if you have any questions. Yes, I think there's a microphone. Here you go. I think hopefully that's working. Yes, no? There's a button over there I have to push. I think it's muted. Here we go, the green button. Here, this one's unmuted.
Okay, so what would happen if any of these JavaScripts would fail to download?
So the same argument can be also made for regular website. You can also fail to download JavaScript for a regular website. The way it actually works in practice, I forgot to show you our beautiful homepage. The way it works in practice is that when you navigate to a particular page, we insert a whole bunch of links at the bottom that start prefetching. And these links basically tell the systems that because it's a prefetch link, it's kind of a lower priority, but what it's basically telling the browsers is like, as soon as you have the bandwidth and time, go fetch me these things because it's very likely that I'm going to need this. And Qwik knows how to generate this, right? When the Qwik executes the application on a server, it observes what things will be needed when. And so when it executes, it produces something we call manifest. And that manifest contains all the information about what parts are needed when. And this manifest can get basically serialized into here. And so in practice, this happens. Now, currently, we only have a set of heuristics to kind of figure out how this is, which set of things we have there. But one of the things you can do rather trivially is you could keep statistical information about what the user is interacting with. And by keeping statistical information, you can do two things. First of all, you can sort this list. You can do better by sorting this list because you are saying, statistically, it's more likely that the user will click here versus over there. So let me prioritize and download this first. This can't be done in a normal systems because normal systems produce a single large chunk, right? So that's the first difference. The second thing you can do is you can notice, like, actually, when I interact with this button, which is very likely, it's also a high probability, not a high probability, but it always means that I also have to download this, and this other piece. And so this information can be fed to the optimizer, and then it can collocate multiple symbols together in a single chunk. See, the thing is, it is extremely difficult to figure out a way to break up your system into small bundles. Once you have lots and lots of small chunks, concatenating them together is trivial. It's literally just string concatenation and putting them in there. It's slightly more complicated, but like fundamentally, it's that simple, right? And so as time goes on, we can even further refine this, and we can basically say like, we can get chunks that have multiple things in there based on statistical information rather than on a set of heuristics that we have right now. So in practice, when you come to these websites, this is not an issue at all because everything gets prefetched. Good question. Anybody else? Is there a mic that you can? Thank you.
Does it require state and the session on the server?
Does it require, sorry?
State and the session on the server.
Yes. So, no. This is written to be completely stateless, so the server does not require to store any state. Not only that, I know we've been talking about server-side pre-rendering, which usually implies that you render on request. In practice, you feed this into the CDN, and you save it. The way I like to talk about it is, when the VMs first came out, and you could open up your Windows VM, and you could like boot it up and open up Excel and do a whole bunch of work in Excel, and then pause the VM by saving it to the disk, and then you can take that file that was produced and then open it on 20 other machines, and they all would come up, and they would all be exactly where you left off in the Excel spreadsheet. That's exactly what's happening here, right? You run this once on a server, you produce a set of artifacts, those artifacts get pushed into the CDN, and then millions of visitors can come to your website, and you're just serving them out of CDN. So scalability is wonderful. We're also specifically designed to work with edge computing as well. So we made sure that it works on Dino, obviously Node, Vercel, Netlify, and so on and so forth. So like all the latest and greatest hot stuff that's out there we can work with. More questions? I think there's a microphone somewhere. Yes. There's a button to make it green.
All right. I have a question. How does the Qwik deals with the inter-component communication? Because your example showed the unidirectional, which is super fun, maintainable, and Qwik favors it, which is really cool. But sometimes we have an examples when one component, interacting with one component, manifests in a change in a completely different part, island, however you call it. So is there any way that Qwik handles that?
Yes, absolutely. So that's this example right here. When I click on this button, a completely unrelated component wakes up over there. It is true that the examples I've shown was unidirectional. It just so happens that these are these examples. You can take a store and push it anywhere you want. And when the store is a proxy, it's kind of like MobX. And when you read, when the JSX reads from the proxy, that creates a subscription. The subscription information gets serialized inside the JSON, and so when the client wakes up on the JSON, it understands that there's a relationship between these components, and this is what causes the component to wake up and render. Sorry, one thing, next question while you're getting your mic. One thing can you get the mic? One thing I forgot to mention is we have a prototype of Qwikify. What Qwikify does is it takes your React components and wraps them in a Qwik component, and then these components can then be used inside of your application. So, question over there. There's a button that says mute. You have to click on it.
I think I pressed it. Okay.
Yeah.
So I wanted to ask, how is your experience on modifying an existing website, a huge one, like the price line or something you showed in the beginning, into using the Qwik framework? How easy is that? Or is it better to start over using the framework? So how is your experience?
So we're at early stages, right? And so in early stages, you probably, it's easier to kind of get started when you start from the beginning. But as I said, one of the things we're working on is this thing called Qwikify. And Qwikify is a way of taking a React component and React and wrapping it inside of a Qwik application so that essentially you create like an island out of React. And then Qwik can, by starting at the root and then converting the root components into Qwik, then the leaves can still stay React components, and then we can lazy hydrate them and lazy wake them up. And then over time, as you get more and more of the application converted, you end up with smaller and smaller islands. And so that's kind of our strategy for doing this. The Qwikify thing just got released, so it's brand new, but that's the kind of the strategy we're going with. Hopefully that answers your question. No, I missed it. Let's see. What did I miss?
Hello? So essentially there's a strategy that has been released, Qwikify.
Yeah, Qwikify, literally this morning.
Has it been tested internally though, in terms of?
We have this because we currently don't have, there is a separate open source project that's working on Qwik component library. But in the meantime, we just want to use material design from React component library. And so Qwikify's role is to actually allow you to run existing material design components in Qwik, right? And so if you can do that, then you can pretty much do anything in terms of frameworks. Another question. I think there are 2 mics, so maybe the next person could get a mic ready before it. It needs to be green. Is it green? It is, okay.
1, 2, okay. There's one more example that I feel like wasn't shown. How does the Qwik deal with HTML element, which in React you would call a ref? So when you need an element to input a focus, so to speak.
Yeah, you're right. I don't have an example for that. Same exact way. You say use ref and then take the ref and data bind it, and then you get a callback and same exact stuff. There's a question over there?
Yep. So how I could debug this? Because we had a bunch of code that get scattered into
that's a good question.
chunks.
So there's a lot of different ways of running it. The one I showed you is with Vit and hot module reloading. There's also a mode where it runs all in a client in a standard way so that no server is involved at all. In that case, you actually are looking on your own source code, which is completely unmodified, and it's all in there. But of course, you don't get to see the lazy loading. For purposes of this demo, I couldn't really show you that. Or rather, it would be not as good of a demo. When you have running it in this mode, it's still a dev mode, so it's all broken up, but it's not minified. In this mode, to put a breakpoint, typically what happens is you click the button to load the code, and then you put a breakpoint, and then you click it again to kind of trigger it. That's one way of doing it. Or you can refresh if you want to make sure that it only fails on the first click. Then you refresh the page, and the browser remembers the location of the breakpoint. You can also do the same exact thing for the server. So in here, there is a button here, and that connects me to the Node.js. So now this is a Node.js source repository, and I can debug Node.js, and then this is debugging the browser, so you can do both of them like that. And the last, if everything else fails, you can always just put a debugger statement. So it is true that you have to kind of reprogram your brain a little bit because now your application is running both on a server and a client, and so the debugging experience is slightly different. But I haven't really found that it's like super hard because the transformation. Well, you might have an experience that like debugging code that you haven't wrote is super hard because the transformation that the compiler, the tooling does is so far removed from the original source code that just super confusing. What you find here is that the transformations are actually very, very simple. They just move code from one location to the other location. And if I click on something, then they insert, that was a bad example. They insert that, they use lexical scope, like there's an extra line inserted on the top. But other than that, the code is identical to what you wrote. So source maps actually work just fine. And it's not a problem in practice. But good question. Yes, man, you're on a roll with your questions. I love curious people. That's good.
1, 2, okay. How about unit testing in Qwik? Do you need to await for every interaction?
No, unit testing works the same way as any other framework. We use Jest right now. We're looking into switching to Vit test and UVU. We might have to add a few kind of helper methods to do it, to help out with it. But other than that, it just works. Oh, the thing I wanted to point out is that we made sure that the code base can run without optimizer. So optimizer is the thing that breaks up your code into pieces. We made sure that it's not a required step. And this is especially important for unit tests, right? Because if the optimizer would be required, then setting up something like Jest would be very difficult because you would have to tell Jest how to do these tricks before it runs, right? But because the Jest actually can run on unoptimized code that you have written, the testing story is actually pretty straightforward. There's a team of 3 of us working on this. There's myself, there's Adam Bradley, who originally did Ionic. Anybody uses on Ionic here? Nobody? Okay, Ionic's super cool. And then Manu, he did a framework for Go. So the 3 of us are working at it. And one of the things that we are trying super hard is to invent as few things as possible, right? If we could reuse something from the ecosystem, we're reusing it. More questions?
Hello, one. I want to ask, how about size of the bundle or the chunk you need to download? Because you said that we decreased the size of initial bundle, but you need to add some metadata related to the Qwik.
Yeah. So the way to think about it is, on the end of the day, the framework needs to have sufficient amount of information about your framework to run it, right? The way classical frameworks get that information is by downloading templates and executing them. The way Qwik gets this information is from that serialized JSON state. And I'm hoping that it's relatively easy to see that the JSON is going to be way, way smaller than the source code of your application, and certainly cheaper to parse than actually executing your application, right? So you're right in the sense that the JSON contains extra information, but in practice, the amount of code you save on not downloading JavaScript is orders of magnitude more than the additional data that's in the JSON. That's one. The second thing you have to understand is that this JSON is tree shakeable, right? Like just like we recognize that certain components can never be edited, in this JSON we recognize that like this data is never going to change. And as a result, it's pointless to ship it to the client, right? So the JSON is really proportional to the complexity of your interactions with the page, not necessarily how large your page is. The other thing you can do is you can actually bring, I haven't talked about it, but if you look at an app, you see that there's this thing called container. It's not called app, but a container. It's because you can have actually multiple containers on the same page, and this works wonderfully for the purposes of micro front ends. But the next trick you could do is you could break your app into smaller containers, and then you can lazy load this stuff. And so we actually do this trick on our homepage. This is our homepage. The bottom of the page is missing. When you scroll, we download the rest, right? And so the experience that the user actually gets to see is this. Come on, right? The user just gets a super fast first render, and because a whole bunch of HTML never got sent to the browser, you're actually saving even more. And then when you start scrolling, we go and we download the rest. And of course, we don't download on the scroll. We like as soon as everything got downloaded, we sent a prefetch instruction to the browser. And so the browser was like, as soon as I'm done doing everything else, because there are higher priority things, I'm going to start downloading the second half of the page, right? And by the time the user figures out what needs to be done, like it's all ready to go. And so when you scroll, it's just inner HTML, that new container, and it's resumable, right? Good question. On this side, no? No more questions? Okay, I think we're out of time anyways. I will be hanging out outside the room. If anybody wants to chat with me, etc., I'm happy to answer questions or talk about anything you want. I'll tell you bad jokes, whatever. So thanks for coming. Hopefully this was super informative, super useful, and it was different from what you're used to. Thanks.